Okay. Hello. So this lesson is about constructing, identifying, and describing compositions of geometric figures. So you'll see this lesson is basically just putting a lot together that we've learned about transformations. So let's start with reviewing some of the important vocab around transformations. Okay. So let's just start first with what these three things even are. A translation is like a slide. We take something and slide it. A reflection is a flip, and a rotation is a spin. Okay, and when we learn these three things, we learned how to do them by hand, how to perform these transformations by hand, but we also learned something called mapping notation. Mapping notation is when we take x, y, we think about the coordinates on the coordinate plane and the rule that's going to happen. So we'll say x, y, and use this arrow to mean maps to. It's basically telling us, it's like a code to describe what's going to happen to the coordinates. So when we do a translation, x, y, the mapping notation looks like this. X, y is going to map to x plus or minus a value and y plus or minus a value to show us that slide on the coordinate plane. Are we going right or left? Or are we going up or down? Okay. For a reflection, we've learned some mapping notations for specific lines of reflection. So when we reflect over the x-axis, the xy coordinates will always map to x and then opposite y. When we reflect over the y-axis, xy will always map to opposite x, y. When we reflect over the line y equals x, xy will always map to y, x. And then when we reflect over the line y equals negative x, xy will always map to opposite y, opposite x. So again, these are patterns we can use to perform these transformations, which will allow us to figure out what the pre-image to image coordinates are without having to graph. Now rotation, if we rotate 90 degrees, and notice all of these are positive, so we're going counterclockwise, xy will map to opposite yx. For a 180 degree rotation, xy will map to opposite x, opposite y. And for a 270 degree rotation, xy will map to y, opposite x, okay? So, let's see some examples of this. We're going to jump to our key points box. So, again, this objective is about compositions of transformations. All that is a series of rigid transformations. In the past, we've dealt with transformations one at a time. Like we've only done a translation, we've only done a rotation, we've only done a reflection. Now, we're going to talk about what it looks like to do more than one transformation at a time. Okay? So I'm actually going to jump straight to example 1. So consider the transformation that would map triangle LKM to triangle L double prime, K double prime, M double prime. So what I'm noticing here is, in order to get from here to here, two things are going on. First, I'm flipping, like I'm reflecting. So if I'm describing the rigid motion in words, it's a reflection, and that gets me to L prime, M prime, K prime, and then I slide. So a translation. Okay? So that's what we're talking about. Like we're going to do when we want to achieve, when we need to take more than one action, more than one transformation to move a shape to a specific particular place. Okay? Now, that's in words. We can also use something called function notation to describe transformations. Function notation is when you see that little symbol there? That means function notation, and that means we're talking about more than one transformation. And when we do that, we read these right to left. So, talk about what's happening here. This is the first transformation. That transformation is, okay, opposite yx. When I go back to here, what's opposite yx? Oh, that's a 90 degree counterclockwise rotation. So that's the first thing that's going to happen to the shape. And then what's happening next? Here, I see x minus 3, y plus 2. The second thing that's going to happen to the shape is it's going to slide 3 left, because it's minus 3 on the x-axis, and then 2 up, because it's plus 2 on the y-axis. Okay, so if I was going to use function notation to describe this transformation, basically I'm noticing that this is kind of like, actually, I'm going to just take this away, because I don't think this is super clear. We're going to actually talk about example 2 now. So here, we're given function notation to describe the transformation, okay? And so it's considering the two compositions of transformations. So, again, this is, this is first, and this is second, whereas this is first, and this is second. All right, so the question is, will the coordinates of A prime or A double prime be the same under both compositions? Well, I'm going to actually map this out. So I'll do this one. I'll do this one in purple. So it's asking me to first translate 2 to the right, 3 down. Right, so A prime is going to go here. Then it's asking me, this is a reflection over the, should be a reflection over the y-axis, because my x-coordinate is going to become opposite, but y is going to stay the same. So I would land here. Okay? So that's what would happen under this composition. Now I use blue for this other composition. Okay? Now, this one's asking me to reflect over the y-axis first. So I'm going to flip it. And that's my A prime. And then I'm going to translate 2 to the right, and then 3 down. 1, 2, 3 down. And get A double prime here. So as you can see, will the coordinates of A double prime be the same under both compositions? No, since the order of transformations is different. Okay? And that is basically it. All right, hope that made sense and that you have a good rest of your day.